So, good morning, class. Today we are going to talk about diodes. Yeah, Joseph Musili. Yeah. So, for a start, what do you think a diode is? What do you think is a diode, or just what comes into your mind when you hear a diode? So, what's maybe you can define what's a diode? So, before we start, we can look at the objectives, what you are supposed to be aware what you are supposed to know before the end of this class. You make sure that you have understood each and every part of the lesson. So the objectives by the end of this lesson, the learner should be able to, number one, you define a diode. Yeah, just you must be able to define what's a diode and explain the working principle of a diode. Yeah, you explain how the diode works and identify at least three types of diodes. You can identify as much as you can, but for now you must be able, by the end of this class, you must be able to state at least two types. And then the last and not the least objective for this class, you must be able to state at least two applications of a diode. You state where you think diode is used. So let's start with defining what's a diode. So a diode, we are told that is a semiconductor device that allows current to flow in one direction only. So from the definition, you have seen that one of the major characteristics of a diode, it must be a semiconductor device. So not just a device, it must be a semiconductor device. It will allow current to flow in only one direction. That means that from the image we have here, from the image we have the anode and cathode. So that this is the first one. This one here, where you are seeing my cursor. My cursor, it's a diagram or an image of a diode. Then the second one, it's the symbol of a diode. So in the cathode, that's where we connect our positive terminal, and at the cathode, in the anode is where we connect our positive terminal, and at the cathode, we connect our negative terminal. So if you connect your anode, your diode, if you connect the negative terminal in the anode, which it will be vice versa, the diode will not conduct or will not allow current to flow. So we have said a diode is a semiconductor device that allows current to flow in one direction only. So when it's flowing in one direction, if the direction is supposed to, it will conduct current in forward bias direction. If you change the direction, it will be reverse biased and it will not conduct. So the working principle of a diode. So just from the definition, we said that diode, they do conduct current or electricity when connected in when forward biased. So diode conduct when forward biased and block current when reverse biased due to the PN junction. So later in this lesson, we'll come to know what's a PN junction. Just for now, just know we have the PN junction is the PN junction is the one which makes the diode to control or to allow current to flow in one direction only. So it will conduct, it will allow current to flow in forward biased, but when it's reverse biased, it will block the current. Or if you are connected a bulb, it won't light. So the next thing is let's talk about several types of diodes. The first type of diode, is a Zener diode. We just highlight for today. Next class we'll look each and every type of diode in details. So for this class we just have Zener diode, the its symbol and an image. It has been displayed on the screen. Then this one here, this is what we call a Zener diode. This is a Zener diode. This is its symbol. We have light emitting diode, LED, that's a diode. We have Scotty diode and photo diode. So remember, we in the working principle, we said that diodes conduct when force biased due to something we call a PN junction. So the next thing I want us to look is the PN junction. So before we go to I show you what's a PN junction. Can someone try to maybe what do you think a PN junction might be? So on the public chat, I can see someone is talking about a PN junction. That's good. You're saying a PN junction is a junction, but you cannot define a word by itself. So thank you for those responses. What's a PN junction? A PN junction, it is formed by combining two types of semiconductors. We have the P-type semiconductor and N-type semiconductor. So when you combine those two semiconductors, that's when you get a PN junction. So when you take a one semiconductor which is P type and N type, another one which is N type, you'll get a PN junction. This PN junction is the one which makes current not to flow when you reverse bias it. So in P type, the empty holes they are the major carriers of electron of charge, and in the N type, the electrons, the free electrons. Remember where we get a free electron? If a metal, all those the delocalized electrons. So that here we have an image of a p-n junction. So I hope you have understood. So the next thing, let's talk about the applications. Where do we apply p-n junction? The diodes. So class, where do you think we do apply a junction? Where have you ever seen a p-n junction? Or a diode? Let's talk about a diode because a p-n junction is in the diode. Have you ever seen a diode somewhere according to the way we have defined it? Good. I can see, Anita, you're talking about rectification. That's good. Yeah, Evelyn Kinyeli on the public chat. I have seen that you're saying we apply diodes in switch. We can use a diode as a switch. That's a very strong point. Yeah. Others, you can give your opinions. Where do you apply? Brian Kipto is talking about application of diode in rectification. I think that we had seen that. So we go to applications of diode. Number one is rectification. As someone had said, we do apply it in rectification. That's the process of changing alternating current or alternating voltage to a direct voltage. This is a diagram for rectification. You can see this D1, D2, D3, D4. These are our our diodes. This is the source of the alternating voltage. Here is a load. So rectification, this is a symbol, a diagram for rectification. So the next thing is voltage regulation. You can regulate voltage using diodes, signal demodulation. This is demodulate signals and light emissions. In LEDs, we do use diodes. So in conclusion, Before we go to conclusion, uh, I want someone to type maybe what's a diode. What have you understood a diode is? You state what's a diode and you give at least one one type of a diode before we conclude the class. Very good, very good. I can see we have so many responses, which was very nice, very good. So conclusion: diodes are key in controlling current flow, voltage regulation, and light emissions in electronics. Almost we do use these diodes in electronics.
How diodes
So
work?
here
This is a diode. It plays crucial role
we
of
have
circuit protection and rectification. Its greatest characteristic is its one-way conductivity. That is, the current can only flow from one direction, forward of the diode, flows through block when reverse. There is a PN junction inside the diode, composed of P-type semiconductor and N-type semiconductor. Due to the existence of PN junction, so a circuit is like a one-way street in a car road. Current is not allowed to flow backwards, otherwise the driving license will be revoked. This is how a diode conducts electricity in one direction. Hope you understand it. Like, comment, share, and follow. How diodes work? This is a diode. It plays crucial role of circuit protection and rectification. Its greatest characteristic is its one-way conductivity.
so that's the end of our lesson. In case someone has a question, yeah, if you don't have a question, we can end our class there. That's the end of our class. Thank you. Let's meet next class.